Hello everyone and welcome to Math 110. We're going to start the course by easing into some simpler concepts in Unit 1 and then just go from there. So today I want to start off talking about prime numbers and divisibility. And divisibility is a concept in which we talk about in order to identify whether or not a number is prime. We say a larger number is divisible by a smaller number if the smaller number can divide the larger number with no remainder. So for example, we say 6 is divisible by 2 because 6 divided by 2 equals 3 and it has no remainder. So it's a simpler concept to see when you see the equation written out there, the division equation, but it gets harder to determine divisibility as the numbers get larger. So the main thing we want to do once we take a look at these a little more in depth is determine how we can see if a number is divisible by another number. But before we get into that, I want to discuss what a prime number is. A number is prime if it is divisible by only two numbers, the number 1 and the number itself. So for instance, if you prime numbers, 2 is a prime number, it's only divisible by 1 and 2 evenly. 3, 5, 7, 11, 13, 17, 19, 23. When we can list them, there are infinitely many prime numbers. It's just any number that has no numbers that divide into it evenly other than the number itself and 1, which divides into every number evenly. So now we're going to talk about testing a number for divisibility, and we're only going to look at some basic tests for divisibility, just these 4 specifically. So we want to see if a number is divisible by 2, 3, 5, or 10. And these are the simpler tests for divisibility. We're not in this class. We don't go into any more depth or look for any other divisibility tests. If a number is even, or if the last digit is 0, 2, 4, 6, or 8, then it is divisible by 2. So we can say that 1,488 is divisible by 2 because the last digit is even, is an 8. 1,487 is not divisible by 2 because the last number is not even, 7. For 3, we look at the sum of all the digits in a number, and if the sum of the digits is divisible by 3, then the number itself is divisible by 3. So for instance, 192, I don't know if that's divisible by 3 right off, but if I take each digit and add it together, 1 plus 9 plus 2 is 12. 12 is a multiple of 3. It's actually 4 times 3, so I know 3 goes into 12 4 times. And since the sum of the digits is divisible by 3, then 192 is divisible by 3. And that's just a quick check if you don't have a calculator handy to try to divide it by 3 and see if it comes out without a decimal. 5 and 10 are really easy. For 5, if the last digit is 5 or 0, so 185 is divisible by 5 because the last digit is 5. In the same sense, 1,680 is divisible by 5 because the last number is 0. As long as the last number is 0 or 5, it's divisible by 5. For 10, we only care if the last digit is 0. So 2,878,920 is divisible by 10 because the last digit is 0. And there are more divisibility rules for the other numbers, particularly all the single digits, but we're not going to go into that in this class. Lastly, in this section, we're going to look at prime factorization. The prime factorization of a number are all the factors or divisors of a number that are prime. And to do that, the easiest way a lot of times is to just make a factor tree. We come out with here and use our divisibility rules. We know that 1060 is divisible by 10. because the last number is 0, so we divide it by 10, and you can use a calculator at this point. Dividing that by 10, we get 106. Now, 10 is divisible by 5 because the last number is a 0, so it's not prime. So we want to keep going until all of our branches on our tree are prime. That's why it's called a prime factorization. So we're going to break this on down. The last digit is a 0, so I'm going to divide by 5. 10 divided by 5 is 2. Both 5 and 2 are prime, so I can stop there because they're only divisible by the number 5 and 1 or the number 2 and 1. 106, I don't know if it's divisible by anything else, but I know it's divisible by 2 because the last digit is even, so I'm going to divide a 2 out of that. 106 divided by 2 is 53. So we see here that the prime factorization is going to be all of these numbers multiplied together because 53 happens to be prime. I can check for divisibility by 3 here. 5 plus 3 is 8. That's not divisible by 3, so I know 53 isn't divisible by 3. And I know it's not divisible by 2, 5, or 10 because it doesn't end in an even number or a 5 or a 0. So at this point, I'm fairly positive that all these digits are prime, all these values are prime. So my prime factorization then for 1060 is 2 times 2 times 5 times 53. And I wrote it in ascending order, but you could write it in any order if you just wanted to write it 5 times 2 times 2 times 53. The software would accept that as a valid answer. And let's look at one more. We'll just make up another number to get the prime factorization of here. 328. So we're not divisible by 5 or 10 here, but we know we're divisible by 2, so just based on that last number there being even, so I'm going to divide it by 2. 2 times 164. I can divide by 2 again. 2 times 82. And I can divide by 2 again. 2 times 41. 41 is no longer even. It's also not divisible by 5 or 10. I could check for divisibility by 3. 4 plus 1 is 5. 5 is not a multiple of 3, so 41 is not a multiple of 3. So at this point, all of my branches are prime. So all of this is my prime factorization. 2 times 2 times 2 times 41. And if it just asks you to list out the prime factors, you would just say 2 and 41 are the prime factors of 360.